been making it for 75 years. We started in 1946, but our origins begin before the war. The country has changed. Our industry. We've been making it for 75 years. Continues to stand the test of time. Like we started in 1946, but our origins begin before the war. And like you, the country's changed. We've been making it for 75 years. We have innovated and changed the game. We introduced the country's first mass-produced curtain-sided trailer, our taut liner, built bespoke for you. And with an ear to the ground and drive to improve, we created the Easy Liner, Load Hold, Auto Hold, and Safe Adjust. With MaxiTRANS, we produce more PBS solutions than any other Australian trailer manufacturer. We are Aussie-made and road transport proud, and our loyal customers have been there every step of the way.
The trust we have in freighter and the reliability that we get out of the trailers is exceptional.
Well, freighter's probably the longest business that we have ever been associated with. They do the job, they're tough and they're reliable, and I wouldn't replace them with any other brand.
We currently have a freighter trailer that's probably older than I am, and that just gives you a bit of an idea that these trailers go for a long, long time.
We consider freighter to be part of our family business. We're quite proud to be associated with their anniversary. It's a very good partnership.
You see it all in 75 years. Drought, fire, flood, pandemic. But we couldn't have done it without you. Freighter is more than a trailer brand. It's a part of our history, a backbone of our industry, a foundation of our future, and it's all thanks to you.
Well, welcome everyone to this session of TMC on the rigid dolly drawbars. And look, I'll just remind everyone, any questions, just pop them in your chat box, and later in the session we'll come back to them. Look, in particular, I'd like to welcome Greg Brown, Engineering Support Manager for MaxiTRANS, Robert Smedley, Director of Smedley Engineers, and Dion Simms from Smedley's as well. Welcome, you three, and just looking forward to the presentation, and any questions we'll attempt to answer. So, Greg, if you want to lead us into the conversation, please.
Thank you, David. Yes, I'm Greg Brown, Engineering Support Manager for MaxiTRANS. So we've put together a presentation for you that hopefully we haven't had a practice of this, so hopefully I can share it with you. If we can get the presentation going. Rob, you can give me a yell when you can see that, can you?
It's just showing the Attendify screen at the moment, rather than the PowerPoint.
Jeepers. Emily, where do we go? Apologise for this hold up, people. There's always an IT glitch. So we do have a PowerPoint presentation for you, trust me. We've as I downloaded it here. The file. A little bit of help down.
If you've got it open, the PowerPoint, now go to the top and go share. And it should say select windows, select whole screen or particular window. If you hit window, and then it should let you select the PowerPoint presentation.
Entire screen.
Yeah, so next to entire screen it says window, and then select window, and then select PowerPoint.
Yeah, I can't see the PowerPoint. Jeepers. Download it again. Apologise for this, everybody. It's always the way. But this rigid drawbar dolly project was conceived by the ITC group, mainly driven by Bob Woodward. Can you see that now, Robert?
Yes, got it. All right, perfect.
How's that look?
That's good.
Okay, so by Greg Brown and Robert, sorry for that little interlude. We needed to start practice a little bit earlier. Apologise for that. So the history is the rigid drawbar dolly was conceived by the ATA and put together by the ITC group, partnering with MaxiTRANS, which is where I'm from, in cahoots with Hendrickson, JOST, Alcoa, Wabco, which is TES now called, they were Goff, and Bridgestone. So we wanted to do a proof of concept dolly, which we built a blue one. So we displayed this at the Brisbane Truck Show a couple of years ago and didn't release it. We'd built ones previous to this, but this was put together with the components from our joint partners, Hendrickson, JOST, Alcoa and Wabco, Bridgestone, and displayed at the truck show. It wasn't the first one we built, but it was one that we could lend out to the industry to do some in-field trials with it. So the dolly was trialled by a wide range of operators, and the operators were asked to provide feedback. And the questions were really, what did you like about it? And what did you not like about the dolly? And we've got some of those answers coming up. We've built many rigid drawbar dollies since that. A lot of the people that trialled it, the drivers would come along and say, we want to buy that, or the owner would buy a dolly like that, and lots of dollies have been sold off just for the difference between a pivoting drawbar and the rigid drawbar is outstanding. The tyre wear was excellent on the trial dolly. It's done 130 or 40,000 and about half life of the tyres, and they're 275/70 tyres, so they're not 11Rs, which generally do less miles. So we expect it to be in excess of 250,000. Some of the feedback from the in-service field trials, and this was the question, what do you like? So this is to the driver, not the guy sitting in the office, it's to the driver. So a lot of these drivers were, hard-nosed road train operators from way back. Some were lesser experienced, so there's a whole wide range of people that did this. So some of these comments were outstanding, minimal kickback, a lot more stable over all road conditions, no kick through lead trailer over bumps and grids, better, less kickback, could not ask for a better dolly. One of the questions was on brake reactivity. So on traditional dollies, when you put the brakes on, the thing nosedives forward, goes clunk. There's a big bang and crack, and when you accelerate, it does the opposite. The question here, what was the brake reactivity like? Answer was none, because there was none. A lot more stable over rough sections, less kickback, it doesn't move around like others, better towing in a straight line. So all these are positive things. A common theme through here, though, and the term was less kickback. So the guy's not getting, the driver is not getting a kick in the back of the seat all the time when it goes over bumps or when he brakes or accelerates. And conversely, we asked, what don't you like? And we got a couple of things. The leg was too short, because it was when we first delivered it. The leg was a bit short, not quite right for the job, so we changed that after a couple of weeks. Needs a raised lower valve, so we fitted a raised lower valve to raise the suspension up and down, just to aid in connecting and disconnecting. We did that after a couple of weeks. It applies some load onto the front trailer, which it does in some circumstances. And you'll see in the testing here, as it goes over a big ramp or a gutter or something, if it sits on the back axle, it does put some load on the front trailer. And conversely, if it sits on the front axle, it lifts up the front trailer. Going down the highway, there's almost no load other than the self-weight of the drawbar on the coupling. So normal highway running, you'd call it no load. One of the other things that were, what don't you like? One guy was, it's painted blue. And I thought that was a great thing, that if that's the worst thing you could find about the dolly, I thought that was it was not going too bad. So in summary, I haven't edited these out. I haven't pulled out the ones where he said it was all over the road. There were just no comments like that. They were all positive comments. Some considerations, though, as we move on with rigid drawbar dollies, because they are relatively new. The coupling selection is important. Some of the current rules limit some couplings and tow eyes that can be used, because it's treated as a pig trailer by some, because it could have some of that vertical load. In real life, it doesn't have much vertical load, and you'll see that in the further down the presentation, very low vertical load. So we just need to fine-tune how those rules are interpreted, and then all couplings will be acceptable, or most couplings will be. Suspension selection, we selected a suspension that had very little bump steer on this, so we had the best, I guess it was. It was a Hendrickson in-track suspension, top mount. The fifth wheel position was in the centre of the two axles, so dead centre, which is where it should be on most dollies. Some argue that it should be forward, but this was in dead centre. And it had an EBS brake control system, so it was a Wabco EBS system on it as well, which aids in lots of things, anti-lock brakes, roll stability, and all those attributes that a EBS system has. So in the video...
Yep. So if you just click another next slide. Yep.
And push play, Rob, do we?
Yep. If you scroll over the video, it should come up with a play button. Oh, it's needing a bit of buffering.
So this is a video of going over some ramps. A little bit of buffering, but you can get the general idea. So that's a pivoting drawbar dolly. It comes up and hits the next trailer. It bashed underneath. So lots of rocking and rolling for the actual frame of the dolly as it goes over a bump. And this is a fairly severe bump, I guess, but it's a what could happen going through a slow speed gutter. So once it catches up, you'll see the the rigid drawbar dolly go over that same bump, and you'll see very little movement in the frame because the dolly behaves just like a small trailer, like a lead trailer in a B-double. Much nicer. So the outcomes overall have been very positive from all the different operators. There's almost no negative comments, and as I say, lots of people have come along and want to buy them. Over to you, Rob.
So as you'll see from some of that physical testing that we conducted, some questions may come up about, obviously, the main thing you'd notice that behaves differently is the chassis of the dolly. And so that's the physical thing you'd pick up on, is that the chassis of the dolly is much more horizontal through gutters or the likes, things like that. In a similar way, the chassis is also very horizontal under braking and under acceleration as well. So in the test, we did some severe brake applications and accelerations obviously after that as well. And that's basically what we're seeing here in this data. So we did in the actual field test though, we did a 80 odd kilometre round loop of country roads around the Corowa or Federation Council outside of Corowa. And we did a few high-speed braking activations, some low-speed braking activations. We did the ramp over test. And there was a mix of roads on that 80 kilometre loop as well. But so we've picked out a couple of the, as attendees of this conference, you're getting a copy of the report anyway, so you can dive into some of this in a little bit more detail. But we've picked out a few of the more noticeable results to present here. And firstly, and this speaks to what people talked about in the feedback of the kickback, or what we've called here cab slap. And so what you'll notice obviously is in the lead trailer, you won't see too much difference between, so we've got here the red line and the black line being the sensors and the pitch rate of those sensors. And as you would expect, the lead trailer, we don't see too much difference in the pitch rate. There's actually a bit of a mistake here. I think, Dion, the red line is actually, in the second graph, the red line is actually the pitch is actually the hinged drawbar, isn't it?
Yeah, that's correct.
Yeah, so that's a typo there on that graph. I'm pretty sure it's correct in the report, but so what you'll see here is actually the pitch rate of the hinge drawbar increases significantly. So this is the chassis of the dolly pitching forward, and when it pitches forward, that's what we see here, a positive pitch forward. But obviously in the hinge drawbar, in the rigid drawbar, because there's no pitching of the dolly, we don't see that result. And then what I'll do is I'll jump to the third graph. In the last trailer, you'll see similarly here the pitching, obviously, as you'd expect in a braking activation, you wouldn't expect too much pitching in a semi-trailer either. So in the first sort of around the 1384, 1386 mark, you'll see the brake activation and the pitching of the dolly. Now, what you, obviously in the rigid drawbar, we don't see that. Now, what's actually really interesting though is in the acceleration after that point. So as we look at, say, 1390 or 1392 second mark, where we progress forward, this is where we see that cab slap that drivers talk about, or the kickback. So obviously in acceleration, you could get that from starting off or a cattle grid or a speed hump or things like that, where you're getting a difference in the forces between lead trailers and tag trailers, or before and after the dolly, effectively. So what it creates is, in the right-hand drawing, bottom right-hand drawing, you'll see what's been identified here as a spring, and this is the torque that's actually applied around the fifth wheel on the hinge drawbar. Now, what you'll see is you end up having this shunting effect or cab slap effect, where in the hinge drawbar that you don't get in the rigid drawbar. So that's the in the last part of the middle graph, where you see the pitching actually start going into the negative part. So we're accelerating, so it's creating a torque around, or a pitching effect around, the fifth wheel. So that's that cab slap or kickback behaviour that you see in the hinge drawbar that you don't in the rigid drawbar. So another scenario, some of you have driven, that may have driven fuel tankers, for example, or cattle, livestock trailers, that shunting of the cab, where after or that ongoing effect of the fuel still moving in the tanks after a sudden stop, that's a similar effect to this cab slap, but this cab slap is caused purely because of the extra degree of movement that's allowed in that dolly, and it creates effectively like a spring in there. So there may be some more questions, but we'll move on to the next slide, and we'll go back to some questions after. So another interesting, we created a measure, I suppose you would call it, and it's a ratio of yaw rate amplification zeroed by the lead trailer. So we basically took the yaw rate of the lead trailer and zeroed it, and then created a ratio between the yaw rates in the dolly and the yaw rates in the tag trailer to show how the yaw rate grows as the combination trailers go on, and the difference between having a hinge drawbar and a rigid drawbar. So anything over 0 is seen as a amplification, and under 0 is an attenuation, and it's a factor of 10 basically. So as that graph increases at different frequencies, you'll see different levels of amplification. So pretty much entirely through the dolly, you'll see an increase on the hinge drawbar. So pretty much all frequencies, the hinge drawbar is worse and amplifies yaw rate over and above a rigid drawbar. And in the tag trailer, the yaw rate doesn't increase as much, but it does significantly increase in certain frequencies above the hinge drawbar. So overall, it's definitely worse, but there are some unique frequencies, probably due to some harmonics or certain wheelbase lengths, and different wheelbases of different vehicles will probably behave differently as well, different loading scenarios, but it's pretty basically there's very little room here where the hinge drawbar performs better in amplification by producing less amplification than a rigid drawbar. Dion, do you want to speak to that? Is there anything you might add?
I'll add for anyone who dialed in just on this slide that same thing applies to this page. The legend's got the colours flipped around. So the red is actually for the hinged drawbar dolly. And this isn't mathematically identical to the rearward amplification that the PBS standards look at, but it's very similar in concept. So this goes directly back to, I guess, an important parameter that's considered for higher productivity combinations. And this is pretty clear evidence that removing that degree of freedom reduces that rearward amplification.
The report is correct. So all of this details in the report. And we'll fix the presentation up after for publication. But next slide. And the last one that's of significance, the not like very visual representation, is obviously coupling forces. We did talk about, or Greg did mention there, that there were some scenarios where the coupling forces are increased, and that is correct, and the data does show that the coupling forces are increased. But the important thing to realise here is that the actual magnitude of the increase is quite small. So we're not talking about significant increases in magnitude of the coupling forces. When you actually look at the scale, it's actually fairly insignificant, the forces, the force increases that we see here. So to be expected, but not definitely not outside the ratings of these couplings. So that's not something to be concerned about. And that's sort of the bulk of the data. I know we've got a bunch of questions here that have come in. And so we'll get to those. And please throw some more questions up in the chat box if you do have any more. Robert Marchetti has asked, has said, Greg, we trialled the dolly and agree with all the comments you made, but my concern is with the lack of experienced drivers and the cost to repair a drawbar if damaged. I think that's probably one for you, Greg.
Just run that by me again, Rob.
So with inexperienced drivers, the cost to repair the drawbar if it's damaged.
Okay, because they turn around, do a U-turn and run it into the back of the other trailer.
Yeah, it might jackknife it or something and damage the dolly.
Jackknife it around it. It is a more substantial drawbar. On that one it is. We've built a lot since then, and now well, two things we've done. One is provide a lot more clearance, so the drawbar is much more slender just behind the toe eye. And this is particularly required for some PBS applications where the drawbar is quite short, so you can't have the normal A-frame type shape. So it is quite narrow. So we've narrowed it down. So that's one thing we've done. And the other thing it's a lot tougher drawbar also in the sideways direction. So when you do jackknife it around, you're probably going to do more damage to the bumper, uprights, or whatever you're going to hit on the truck, which does add to the expense on that part. But the drawbar would survive, so you perhaps don't have to touch the drawbar. You just might have to do a little more on the truck. But I think the narrow drawbar is better. It's better than an A-frame one even. So if you don't hit it, that's even better than hitting it and repairing it. So, yeah, fair point, but the drawbar probably survived better than the trailer.
Next question that I've seen. I'm jumping in there for you, David.
You're right. No, that's fine.
Sorry, I'm not giving you much room to speak. So Andrew from Davals has asked how much wear on the bottom side of the toe eye bogey pig trailers were bad for wear under the toe eye. I haven't seen under the toe eye since we did the testing, so I didn't notice any sort of significant wear underneath it when we were in Corowa, but I haven't seen it for a few months.
Yeah, I think because the load is not very high, as I said during the presentation, that it can load it up while you're manoeuvring around the yard, driving over ramps like you saw in the video. But going down the highway, it really is only the weight of the drawbar, and that's typically what you get with a pivoting drawbar dolly. It's the weight of the drawbar that's resting on the tow coupling. So this is about the same load, so I would expect the wear to be about the same. This particular dolly that's been running around for a couple of years, there's no significant wear on the bottom of the tow eye to date, and I wouldn't expect any because there's no more weight.
I've got a
big... And I presume, Greg, you'd see that in the ring feeder coupling with your nylon pad anyway, probably easier than the towing eye. You'd expect the nylon pad to wear, and you'd notice that if it was worn, I'd suggest.
Yes, but because there's no more load on it than a normal pivoting drawbar dolly, if we call that normal, it's got 50 kilograms on it, whatever it is at the front of the drawbar. This is about the same load. So running down the highway, it's got the same load. There's no more load. There's no load from the second trailer because the fifth wheel is directly over the centre of the suspension. Okay. So I wouldn't expect the wear to be any faster.
Yeah, and the airbags are levelling out. So obviously on a rigid drawbar, you don't have two height control valves, one on the lead and one on the tag axle, or lead axle and trailing axle. So you don't have different air pressures in the two axles, which means that the trailer actually loads very evenly. So you're not forcing any extra load through the coupling as a result of that either. There's about 60 odd viewers at the moment on, and we've got a question up, a poll that we've asked it. So I'll just make everyone aware of it. Would you consider using a rigid drawbar converter dolly in your fleet? So there's some options there. Definitely still undecided. No, I wouldn't. So just draw your attention to that poll. So if you can chuck your votes up there, be good to see some results from that and some feedback of what people's thoughts are. There's a long question here from Barry Hicks, and I'll just work through it. There's three parts of his question. All right, so probably the first part of the question that I'll talk to here is what airbag suspension profile are you running on the new dolly, and in your opinion, is it okay to couple the ring feeder, say up to 100 millimeters higher, using up the suspension manufacturer's specification tolerances? I am not 100% sure of what, Barry, what you're referring to with suspension module profile. But with regards to coupling height variances, ideally you're going to want to match the height of the tow eye to the height of the ring feeder, ideally. But at the same time, I don't see that being vastly different to trucks being coupled with semi-trailers with vastly different fifth wheels. So dynamically, we can have 120, 140 mil height differences between the fifth wheels on prime movers, and we don't see significant, obviously it's not necessarily ideal, but in day-to-day applications, we don't see significant problems on road in terms of suspension problems caused by that. I think further to that, even in, many of you would be aware, on flat deck trailers or curtain-siders from loaded to unloaded, the whole reason that the flat deck is actually made with a curve in it is because as the weight is applied to the flat deck, the chassis straightens out. And you can see anything, to my experience, 50, 60 mil deflection changes in that, which is exactly the same as what's happening here, is a pitching effect of the suspension loaded to unloaded. So I I wouldn't imagine that to cause any issues from a suspension point of view. But not being a suspension expert, I might be speaking a little bit out of turn. But Greg, have you got any thoughts on that?
Yeah, I think you're right. This dolly, which is a 2-axle dolly with a quite close spread suspension, they're typically 1200 or 1350 apart from each other, depending on the length of the drawbar. But if you compare it against a typical tri-axle trailer, a 13.5 metre, 45-foot trailer, suspension spread of, say, 2.7 metres, so much wider spread, you lift the front of the trailer up and down, that over that 2.7 spread, there's a significant difference between the front and rear axle. It can be. As the trailer deflects, as Robert said, and different fifth wheel heights, you move the trailer up and down, that the axle will go up and down 20, 25 mil, perhaps, relative to the back axle. It'll go the other way, pivots about the centre axle. So that's pretty typical. What it really does, not sure. It doesn't seem to affect things because we do it every day in our industry, either tandems or tries. We use up that plus or minus 25 mil away from the suspension ride height. So it's very common in the industry and doesn't seem to have any adverse effects on anything.
Yeah, there's plenty of short lead trailers running around as well.
Yeah.
Point 2, when the tyres on the new type dolly wear out, we suggested a trial you fit fully treaded tyres across the trailing axle and leave 10% treaded tyres on the lead axle. Has this been done? I'm not aware of that suggestion historically, but I'm assuming this is pointing to the same sort of effect of the as to point 1. I might be wrong, but as in I'm thinking if I'm reading this right, it's talking about creating or inducing a suspension height variance, similar to the idea of a coupling height change. So I think we've talked about that. And then there's a third part is, are we comparing apples with apples? You have a new rigid drawbar and a static suspension profile, comparing with conventional dollies, some with up to some dollies, some up at the front frame profile, with static or down at the front. Maybe
I think what I might be getting to here is that the dolly frame is either running uphill or downhill, and that's what you get a bit with a pivoting drawbar dolly, depending on the suspension. Whether the front is high or front's low, and people set them up high and low because there's lots of opinions of what's better and worse. And that's typically from a spring suspension dolly that naturally falls over to the front. Because if it's got a pivoting suspension, pivoting fifth wheel and a pivoting drawbar, there's nothing to hold that frame straight. So people do all sorts of rotten things like packing up the fifth wheel, locking up the suspension, making it into two single axles, and that's what happens when it's an air suspended trailer. Typically there's 2 ride heights, so it's 2 single axle suspensions on that dolly and a pivoting drawbar and a pivoting fifth wheel. So I think that's what is getting to in the question there. If the dolly frame is not quite straight. And that's the whole crutch of the rigid drawbar dolly, is keeping that frame. It's just like a lead trailer in a B-double. It's a little trailer. So it keeps that frame at that level, dictated by the coupling height and the suspension height, and it doesn't flop around like a normal dolly. And that's really the benefit of the pivoting of the rigid drawbar dolly. It doesn't flop around.
So rather than putting Band-Aid solutions to fix sort of things, realistically, the rigid drawbar is directly solving the problem created that other Band-Aid solutions are trying to address.
Yeah, and some of those Band-Aid solutions, packing the fifth wheel, locking it up, generates enormous forces if it does sit on one axle driving through a gutter, like the demo in the video. if that had a locked up fifth wheel, that would generate enormous forces on the fifth wheel and the kingpin. Or conversely, if it had a locked up suspension, it would, the frame, as you saw on the pivoting drawbar one, the frame actually contacted the second trailer, the two chassis hit together. So that sort of stuff happens. It's, generates enormous forces when you start locking those bits up and very short lever arms. So I'm not sure we've answered the question there, Robert. I might have.
As best that I can understand it, I suppose. Alan Whiting from Truck Sales has asked for A doubles as well as road trains. Yes, Greg can talk about this as well. But so this was trialled in 45-foot trailers was the practical testing that we did. But the dolly, to my knowledge, has been used in AB triples and A doubles and BA triples and all sorts of applications. Not just, I think for the most part, it actually wasn't used in PBS. It was actually used in
Type
1 road trains. Yeah.
Yes, it was. It was in road trains because of the difficulty of getting it into a PBS because it's not in the PBS certification. So it was generally in typical road trains of all sorts of combinations. But there are lots of these running today in A doubles, and that's where I was talking about the very narrow drawbar that I was talking about before, because often they're very short drawbars, so they can't be the A-frame type shape. It needs to be narrow, otherwise you can't turn around. So yes, it's okay for A doubles or road trains, whichever. And soon, hopefully, it'll be okay for trikes or dollies as well. And that the only issue with that today is the coupling issue, how the coupling is deemed to be rated.
Yeah. Glenn Fulton from Visi has asked, were there any tear weight differences between the two designs?
No, it's almost identical. And I've answered this question to Glenn. They are almost identical. And as we reduce that drawbar down in width, we've actually taken weight out. So call them the same. They're the same within kilograms.
For those that have voted, I'll just give you a little bit of an update. It's 75 definitely, 25 still undecided, and 0 no, I wouldn't. So just as an update on that progress of that vote. Barry has commented again. We found the conventional dolly. We found the conventional dolly, the up at the front adjustment was a serious problem, and the slightly down at the front adjusted dolly was excellent on the road. I'll probably take that as a comment, I suppose.
Yeah, we're good to know whether they're spring dollies or air suspended dollies. But difficult.
I think that there's a lot of variances within that scenario as to what would affect its performance. But I think in summary, I suppose you could actually say to Barry's initial comment, are we comparing apples with apples? Well, I don't think we are comparing apples with apples. We're comparing chalk with cheese. The reality is a hinged drawbar dolly is not a good solution. Dynamically on the road, doesn't produce good tyre wear. So they're not apples and apples because one of them is just much, much better than the other. And there's very little evidence to suggest that a hinged drawbar is better than a rigid. So not from any, there's no scientific basis anyway for it, for a hinged drawbar to be better. Ian Thompson's asked, is there any plans to test ball race versus semi-oscillating fifth wheel?
Yeah, I'm just not quite sure what the semi-oscillating fifth wheel. Do you mean a fifth wheel on top of a ball race, like a conventional pivoting fifth wheel on a ball race? That could be on this dolly and it would behave the same. Ball races are fairly rare things today in our experience, in MaxiTRANS experience. Whether that's what you mean by the semi-oscillating fifth wheel, or is it the oscillating fifth wheel sideways used on tankers traditionally? Yeah, not sure, Ian, what you mean there. But give us a call and I'm happy to talk to you.
Glenn Thornton's asked another question. Can we anticipate that the NHVR will mandate the rigid drawbar design on future PBS approvals? I have, from a PBS perspective, I haven't, jurisdictions and stuff haven't mentioned anything to me about mandating it on PBS. Some of them have talked about it as being a benefit and something that they would like to see more of, but they haven't indicated that it would be something that they would mandate. I think one of the challenges of the PBS system is there are 16 standards we have to assess to, well, 20 technically, but 16 in practice. The tests, the PBS tests aren't exhaustive. So we don't test things like straight line deceleration or there are some braking tests, but we don't look at things like imbalance brakes on a PBS combination. They're just assumed to be balanced. We don't look at braking on split mu surfaces or things like that. So originally, for those that aren't aware, originally there was something like 80 or 100 or 120 different standards that the PBS scheme originally looked at, and that was narrowed down to 16, 20 standards. So there may be scope for some of that to change in the future, but I don't. Word on the street with regulatory bodies isn't that they're looking to mandate a requirement like that. I think if we were to see a move to the rigid drawbar in PBS, it would be because of improved performance outcomes that would give better results on a PBS approval, i.e. it might give better tyre choice, it might give better payload height outcomes, things like that. It wouldn't be necessarily because it was a mandated requirement, but more that it gave a better performing vehicle, which resulted in more productivity in some way. That would be my take on it anyway.
Yeah, I think today, because there's no allowance for the rigid drawbar dolly, the advantages of it are not really used in the PBS assessment. If from the tests that you've seen here, the high speed off tracking and the high speed lane changes are better. I think if they were actually used and given some credit, people would go to a rigid drawbar dolly because they might get over the line where the pivoting drawbar would not pass. But today there's no differentiation between them. So it might happen one day, Glenn, when the NHVR get up to speed with the actual difference between pivoting and rigid. I don't think that's going to happen in the short term, though.
Mataranga has said, hi, Brownie, Rob and team. As Brownie briefly pointed out, some guys like the fifth wheel on a dolly to be a bit forward of the centre of the axle. Is that a complete no in this dolly, or can that be achieved by going for coupling with a higher vertical load support?
I'll take that, Rob. We try not to put the load on there. In this case, I don't see too much advantage in having the fifth wheel ahead of the centre of the suspension. And true, it will put some load on the coupling, depending on the length of the drawbar. The longer it is, the less the load. Shorter it is, the more the load. It's not a desirable thing to have too much load on the coupling. a ring feeder's rated at 1,000 kilograms on the coupling. We wouldn't want to really get up to that because you do start wearing it out faster. I'm not quite sure why we would want to do it in this case. I think they do it on other ones to try and get a bit of stability to stop the dolly frame pig rooting, flopping up and down. In these dollies, that's not required. So I'm not quite sure why we'd want to do it, but I think we could. 50 mil ahead with a 4 metre drawbar is not going to put a lot of load on the coupling. So it could happen if you really thought it was super, super important.
Yeah. That's the way I'd say it. If you saw that it was needed, you could. But I think the whole reason people offset the fifth wheels on a dolly is to try and overcome the poor performance of a hinged drawbar dolly. Yes. So if you move to the rigid drawbar, that in itself handles the poor performance, which means you then no longer need to put these other band-aid solutions like chocking the fifth wheel, putting the fifth wheel forward, blocking suspension. None of those things are needed because you've actually dealt with the root cause by making it a rigid drawbar.
Yes.
Which over and all is going to improve the longevity of the fifth wheel. It's going to improve tyre wear. It's going to improve the suspension life and other things like that. So I think overall you're going to end up having a better dolly that's going to need less maintenance than a hinged drawbar dolly that actually has all of these other band-aid solutions on it that end up needing constant, inspections and maintenance and extra fatigue and wear on kingpins that you wouldn't otherwise have. So I think I would expect overall you'd probably see less maintenance requirements on the rigid drawbar because you have less components pushed beyond their ratings and wearing out as a result.
Yeah.
I think one of the other interesting things that Glenn sort of touched on and asked about whether the tear weights were significantly different on the dollies. There is actually opportunity to even look at, because you've now got a dolly that isn't pitching and hitting chassis and fouling against other components, there's actually probably scope to look at reducing tear weight of a rigid drawbar because you don't have to accommodate clashing between semi-trailer and the dolly. So there's potential there for weight savings anyway. And
yeah, I think you're right, Robert. I think over time the weight will come out of it. If you think of the rigid drawbar dolly as a small lead trailer out of a B-double, it could be built with the same structure as the lead, the back end of the lead trailer. These dollies are a bit heavier than that. So it could be just like the back end of a lead with the main rails go out the front to the coupling. So I think you're right. Over time, the weight will come out of it. We've ended up with these heavy dollies because we keep chasing dramas that go wrong.
Yeah.
Keep adding steel. So I think you're right. It could get lighter over time.
Though it wasn't significantly heavier, though, than a conventional hinge.
It's not. No. Yeah. So I see Ian's come back with the ball race semi-oscillating versus just the oscillating fifth wheel. Yeah, adding a ball race to the dolly, I don't see any issue in adding it or not adding it. I'm not sure what the value of the ball race is, but certainly there's no issue adding a ball race to the dolly with whatever fifth wheel on it.
Barry Hicks mentioned, have we considered safety chains for the coupling?
Considered it for about half a second. With the rules the way they are, with a pin type coupling, you don't need the safety chains. That's what the rules are. Other type couplings, you do need safety chains, and if you follow the ADR rules, the safety chains are big enough to tie a ship up to. So they're massive things that most people don't like handling. There would be no issue putting safety chains on it, but I'm not quite sure why you would. So you could. Typically they're 13 mil diameter chains that end up on these things, and that's dialed up by the ADRs because of whatever weight's behind it. So they're quite beefy chains. Something that you've got to handle. You've got to hook it onto something on the back of the other trailer. So you could have it if you wanted to. There's no issue, but we wouldn't do it unless either the customer wanted it or the rules mandated it. Because today dollies don't come off the backs of trailers too often, thank goodness, because the couplings work. So I thought about it for about 2 seconds, Barry, if that's any help.
All right. Currently, the votes are at 85% definitely, 25% still undecided, and still 0% no, I wouldn't. So I take that as we've done a pretty good job of selling the rigid drawbar to industry. I don't think we've missed any questions there.
Yeah, I think that's all the questions. Yeah. So our job is done. We've solved it. And if I put on my MaxiTRANS hat here, this is not a selling rigid drawbar dolly exercise. At the end of the day, as a manufacturer, we don't really care whether we build a rigid drawbar or a pivoting drawbar. So we're not pushing a barrow here, but the outcome of a rigid drawbar dolly is so much better than a pivoting. For the benefits of the industry, we're pushing the barrow, not for the benefits of the manufacturer. So it works so much better.
Actually, I'll just throw a bit of a left field question in, but it's probably a little bit more critical to. I'm just thinking if you got a short drawbar, like a fixed short drawbar, and if you run multiple trailers, meaning drop decks, flat tops, etc., it'd be a bit more critical to have a fixed drawbar at the right height. A pivoting drawbar, at least you've got a bit of flexibility when you're interchanging trailers. So that's just it's a comment more than a question, really. But yeah.
Yeah, true. That's to Barry's original question. The shorter the drawbar, the more critical the height becomes, because if you shift it up 100 mil, it's significant for the suspension. But if it was a long drawbar, 100 mil is not much.
Yeah.
So fair point. Very short drawbar, you just need to keep it a bit more right to the right height. And typically the short drawbars are in PBS combinations. So they generally dedicated units that stay together, or they go with the same unit. So the heights would be controlled. But fair point. The shorter it is, the more critical it is to be the right height.
Yeah, and I guess I was referring to a fixed drawbar where, a pivoting drawbar, you've got a little bit of leeway, but it's really only where you're interchanging trailers regularly and you've got mixed heights. But
if you've got mixed fleet where that would happen, again. But at the same time, I'm not. I foresee that there being a bit of innovation in this space where it's not unrealistic that we could end up having bolted toe eyes, where the toe eyes can be at different heights, for example, on the front of the drawbar, or the drawbar, rather than being, a continuous chassis beam, for example, it could be bolted onto the front of the chassis at different heights, or some sort of arrangement. So I don't necessarily see that as a showstopper. I think that's more of a should the need arise for particular fleets, I have more than enough faith that trailer builders can come up with innovative solutions that would provide a trailer that could have multiple coupling heights. Yep. Would you agree, Greg? I think there are probably many ways that trailer builders could skin that cat.
Yeah. All right. We're in the.
We want to be bolting and unbolting toe eyes on the side of the road, but yeah.
No, it's fine. It was more of a comment, like I said. But yeah. Well, we're in the final seconds of this session, so if anyone's got a last question they want to punch in. But is there any final comments, Greg or Rob, you want to throw in the hat?
Oh, no, this has been a great project, and it was conceived by the ATA, so 10 points to Bob Woodward of the ATA. He drove it. We're building rigid drawbar anyway, but he's really got it out there, and this session is because of him. So 10 points to the ATA and Bob, I think, and they work. They're good.
Yep. Yeah. Do you want to make a comment, Rob, before we close?
I think I'm going to defer to Dion actually on this one. As someone new to the heavy vehicle industry, but not new to automotive industry, what was the biggest thing that you took away from this project? What was the thing that you were really surprised to see?
To be honest, I've been trying to work out for about the last 6 months why the hinged drawbar dolly came about in the first place. I don't know. I guess it probably evolved through different coupling types that weren't quite as robust as what we use today. But I haven't come up with a good reason, apart from it's what we've got and it's what we use. I haven't come up with a good reason why the hinged one is the predominant dolly. Dynamically, the rigid drawbar dolly with a load share seems like, from a dynamicist point of view, it seems like a better solution all round. So to be honest, that's what I've taken away from this. Is I'm still scratching my head trying to work out why the predominant one is the predominant one, the hinged one.
Well, fair comment, actually, Dion. Yeah.
Good. I think that's a good wrap up.
Yeah. All right. Well, look, thank you very much, Greg, Robert, and Dion for presenting in this session. Thank you, everyone, for viewing this session on TMC. And look, we'll wrap it up at that. Thank you very much, everyone.
Thanks, David. Thank you.
Okay. Yep. Bye.